Welcome to another video. Today we're working with charging systems. So we're going to look at alternator voltage output, current output, and also take a look at how we would do voltage drop testing for the alternator and charging circuit.
So our first test is going to be just a basic voltage check of the system. So we're going to get our voltmeter out, DC volts, get connected to the battery just like we would for open circuit voltage, take a quick look at what we've got just with the vehicle off. This battery's a little low. Next we're going to start the car and we're going to look at what does the voltage elevate to, and this will give us some idea just that the alternator is functioning and it is contributing voltage to the system. And depending on what the vehicle accessories are doing or what the battery needs in terms of a charge, this number will fluctuate a bit, but we should be in the high 13s. Next, we're going to do a current output test with this old Sun VAT40 tester. We get the 12 volt connection set up. We're going to take note of where our voltage is at once we get those connections made. We're at about 12 volts. And so we're going to next get the current clamp set up. That's my green clamp. I'm going to pay attention to the arrow for polarity and put that on the output wire of the alternator. Once we've got that set up, we'll go back, we'll get the car started, and we're going to look for what the current output is. It's going to be a little high on this vehicle because of the discharged battery. And next we're going to use the carbon pile at the top, and we're going to add a load to create a demand on the system. And so we want to create a load just large enough to pull the system voltage down to the open circuit value of the battery. So in our case about 12.1 volts. I don't want to be lower than that because at that point I'm taking from the battery. And so when we do this, we exceeded our 100 amp scale. We switch scales, repeat this test, and it looks like on this Toyota we're getting about 100 amps out of the system. Here's one more shot, you can see a little bit closer, and so we'd compare this one to the specification for rated output. This next one is a variation of the previous test, and where I'm going to use an amp clamp or current clamp tied to a voltmeter rather than use that large Sun tester. Say we don't have one of those. Most of us as technicians have a small current clamp like this. I'm going to set it to the larger scale that goes all the way up to 400 amps and make sure that I am on DC, and once we get it plugged in and everything, we'll verify that we're zeroed. This one, it outputs in millivolts, so I hook it up to my voltmeter, go ahead and set to volts and verify that I've got everything zeroed. There we go, we've got 0, and we're going to take this and we're going to place it in the same location right on the alternator output wire. Take note of our polarity and try to keep it out of the way of the exhaust and anything hot. With that set up, I'm going to verify this is with the vehicle running. It's just like we saw in the previous test, there's quite a bit of output occurring just to charge the battery. And so now I'm going to use a different tester. This is just a battery load tester. And I'm going to use this to put a demand on the system just like we did before, and we see we're getting right in the neighborhood of 85-86 amps worth of output. That's the conversion, is 1 millivolt per amp with this specific amp clamp. So here we're just going to repeat the test one more time. This is with our engine idle elevated, and we're getting about 85 amps again. And this is pretty close to what we saw on that older VAT40 analog gauge set. So here's another look at it, so we can be kind of extra and get some additional information, see it all at once. We're going to do the same test, but we're going to use the PicoScope, Oscilloscope to look at the voltage pattern as well as the current output. So we get that set up. We've got it scaled here, and we've got to zero our amp clamp. We do that on the screen with the newer amp clamp setups with Pico. And next we'll go ahead and get a long trace so we can watch it go across the screen. Start the vehicle and we'll take a look at the results. So here we go ahead and crank. We see a dip in voltage. Alternator comes on board, starts charging, and then I'm going to use the battery load tester again right here to put a load on the system, and we can see that dip in voltage. The ruler guide that's placed is the open circuit voltage for the battery. So here we'll go back and look at the trace. So again, we can see just our idle point, or starting point here, Vehicle cranks, we go to idle, we start to see some output, and then here is our test where the battery is being loaded to create demand and output. And much like our other tests, we're getting pretty similar numbers. So here, if we zoom in and take a look at just this little section, we can see that rise in current output where we've got about 78 amps, and we saw that decrease on the voltage from the battery load tester. For our last test, we are going to set up and do a voltage drop test on the charging circuit. So this test helps me understand if my connections are good and free of any additional or unwanted resistance. So we're going to set up our voltmeter, DC volts, go ahead and range it just so that we can stay in whole units. And we're going to take our leads. One lead is going to go on the output. We're going to check the positive on the output cable side first. The other connection is going to go on the positive post of my battery, and then I've got to repeat just like we did before. Vehicle is running, and we're going to use the battery load tester to put a demand on the system. And we can see that this has even got just a little bit of drop, about 0.2 at that 50 or so amps like we saw previously. So here we're going to add some load, pull that battery back down toward its open circuit, and we get an output and a drop of about 0.43 volts, which is just under the threshold of a half volt. Anything more than a half volt we would want to be concerned about. This next one, we're going to do the ground side. So here, just kind of scraping onto the case of the alternator, get a good connection, take my other lead and go to the negative post of the battery, and repeat, same process. We're going to put a load, pull that system voltage down, get the alternator running, producing some amperage, and this one passed much better. We've got a much lower drop on this side, less than 1/10 of a volt. Not much to think about.